Welcome to the Deep Dive. Today we're tackling something actually huge, maybe even revolutionary.
Definitely ambitious. We have to start with that Arthur C. Clarke quote, right? He thought this line of research hinted at something bigger than the atomic age.
Yeah, that's quite the statement. So our mission today really is to try and weave together some threads. We've got these seemingly separate bits of research: physics, biology, consciousness.
From some brilliant scientists, yeah, sometimes working way outside the mainstream.
And they all seem to be pointing towards this single kind of radical idea.
That the universe is fundamentally connected, like an energetic web. They call it the zero-point field, or just the field.
And the kicker is, we're not just watching it. Our consciousness, our minds are somehow involved, like actually influencing it.
Exactly. It really pushes back on, well, a lot of standard science. It makes you ask, what if our models for physics, for biology, even for the mind, are just incomplete?
What if there's this deeper coherence we're missing?
That's the core question. So let's dig in. Where does this start?
Okay, let's set the stage. There's this sort of crisis brewing in science. One source we looked at even says biology is maybe 400 years behind physics.
Wow. Yeah, you can see that. Physics, especially quantum physics, hit this wall early on. The pioneers, they realized observation changes things, right? A particle's state isn't fixed until you looked.
But they couldn't figure out how to actually fit consciousness, the observer, into their math.
Right.
It just didn't compute.
Right. It felt messy, unscientific almost. There's that great quote from Lichtenberg back in the 18th century. He said, if an angel explained these deep concepts, it would sound like 2 × 2 = 13.
Just fundamentally illogical to the way we were thinking.
Exactly.
So, okay, to bridge that gap, we need this.
Yeah.
The zero-point field, the ZPF. What is this thing? This ocean of energy.
Right, the ZPF, it's basically the energy that's left even in what we think of as totally empty space, the vacuum. It's not truly empty. It's teeming with these microscopic fluctuations. Tiny virtual particles popping in and out of existence, exchanging energy super fast. It's the baseline energy level of the universe, even near absolute zero temperature. That's the 0 point part.
And the energy level isn't small. You used the word immense before.
Oh, it's staggering. Richard Feynman, the Nobel laureate, did a calculation.
Yeah.
He figured the ZPF energy packed into just 1 cubic meter of space, you know, like a box about 3 feet square, has enough power to boil every single ocean on Earth.
Okay, that's almost impossible to grasp. All that energy just sitting there in the background.
Permeating everything. It's the ultimate cosmic backdrop.
Which then leads to some really wild ideas about fundamental forces.
Yeah.
This is where Hal Puthoff, Alfonso Rueda, and Bernie Heisch, the Sharp team, come in, right? Redefining gravity and inertia.
Yes, building on an idea from Andrei Sakharov, they started asking, what if inertia, you know, an object's resistance to being pushed, Newton's F/y fixed, what if that's not something inside the object?
So not an inherent property.
No.
Then what is it?
It's an effect of the ZPF. Basically, inertia and gravity are like drag or friction.
And friction against what?
Against the ZPF itself.
Yeah.
When the charged particles in matter, the electrons, the quarks, try to accelerate, they're bumping against this constant storm of ZPF vibrations. The faster they try to move, the more resistance they feel.
So inertia is the universe pushing back via the ZPF.
That's the idea.
And if it's resistance,
Yeah.
that means theoretically you could maybe cancel it out.
That's the implication that got people excited. If you could somehow shield matter from those specific ZPF frequencies causing the drag.
You'd eliminate inertia, which sounds like, well, science fiction.
Yeah.
Instant acceleration, maybe even tapping that energy.
It's definitely futuristic. Arthur C. Clarke was so taken with it, he put a ZPF-based inertia canceling drive in his novel 3001, The Final Odyssey, based directly on the Sharp team's work.
It also changes how we think about mass itself, doesn't it? If it's tied to this ZPF interaction, what about ECPF?
It reframes it. The Sharp team suggested mass is that interaction energy. Immensior isn't just about converting mass to energy. It's saying mass is a specific amount of organized ZPF energy.
So fundamentally, maybe there's no stuff, no mass, just charge and energy interacting with the field.
That's the radical conclusion. Not objects in empty space, but patterns of duration in a universal energy field.
Okay, mind blown on the physics front. But if this field is everywhere, how does it show up in, well, us?
Yeah.
In living things. Let's shift gears to biology. Fritz-Albert Popp.
Right, Popp and biophotons. He discovered that living systems constantly give off these ultra-weak streams of light photons, not just random heat, but something more organized.
There's that weird inverse relationship with complexity, right?
Exactly. Simpler organisms, like bacteria, might emit, say, 100 photons per square centimeter per second, but complex ones, like us humans, emit way fewer, maybe only 10.
Less light means more internal organization, better use of it.
That seems to be the case. But the really crucial part is the kind of light. Popp showed it's highly coherent.
Coherent, like a laser beam. All the waves in perfect sync.
Precisely. Not like a chaotic light bulb. And that coherence is key because it allows for potentially instantaneous communication across the entire organism, faster than nerves or chemicals.
Like a body-wide light-speed internet.
Kind of, yeah. A coordinating network. And this was stunning because that level of coherence, like a Bose-Einstein condensate, was thought only possible in extreme lab conditions, super cold, non-living matter.
But Popp found it happening in warm, messy, living biology.
Constantly, suggesting life is fundamentally organized by this coherent light field, likely interacting with the ZPF.
Okay, coherent light, instant communication.
Yeah.
This feels like it's leading towards the really controversial stuff.
Yeah.
Jacques Benveniste and the memory of water.
Ah, yes. Benveniste. It started with an accidental finding. He was working with antibodies and basophils, a type of white blood cell.
And he diluted the antibodies a lot.
Extremely diluted. So much so that statistically there shouldn't have been any original antibody molecules left in the water, just water.
But the basophils still reacted.
They did. As if the antibodies were still there. It looked like the water itself had somehow remembered the antibody's presence.
Which sounds like homeopathy, or worse, to mainstream science. I remember the Nature publication, they published it, but with a warning label, basically.
They did, and then they sent this investigative team, including a science magician, James Randi. Benveniste felt it was a setup, not a fair scientific inquiry.
Huge controversy, but he kept working on it.
He did. And his later work is where it connects back to Popp and the ZPF. He started thinking it wasn't the physical molecule doing the work, but its electromagnetic signature, its frequency.
The specific vibration of the molecule.
Exactly.
Yeah.
And he developed ways to record these low-frequency signals. He could digitize the signal of, say, histamine, send it electronically, and then play that signal into pure water containing biological cells, like pig heart cells, sensitive to histamine.
And the cells reacted.
They reacted just as if the actual histamine was physically there.
Wow. So the information of the molecule carried by frequency was enough.
That was his claim. It suggested molecules communicate information non-locally, likely using the ZPF as the carrier medium, not just physical bumping.
Okay, so if molecules communicate via frequency through the field, and our bodies are organized by coherent light fields, then our minds, our consciousness, must be interacting with this field too. Let's go there. Karl Pribram and the holographic brain.
Right. This tackles the age-old problem of memory. Where is memory stored? Carl Lashley spent his career searching for the enneagram, that specific spot in the brain holding a specific memory.
And he never found it, right? He'd removed parts of rat brains, but the memories seemed to persist.
Correct. No matter which part he took out, the memory may be degraded, but it was still accessible. It wasn't stored in one location.
So Pribram comes along and says, it's like a hologram.
Exactly. He proposed the brain doesn't store memories like files in specific folders, but processes information using wave interference patterns, mathematically similar to how holograms work. Fourier transforms, technically.
Meaning the memory is distributed everywhere at once.
That's the idea. Just like if you break a holographic plate, any small piece still contains the whole image, just maybe fuzzier. Memory is encoded in the pattern of waves across the brain, not in individual neurons.
There was that kind of disturbing experiment with salamanders that seemed to support this.
Ah, yes, Paul Peach's work. It sounds brutal, but he was trying to disprove Pribram. He surgically scrambled salamander brains, chopped them up, squeezed them, even reshaped them completely.
And the salamanders.
After recovery, they largely retained their normal functions and learned behaviors. It strongly suggested the information wasn't localized, but distributed holographically throughout the tissue.
Okay, so the brain is like a holographic interface with this field. Then consciousness. It shouldn't just be reading the field. It should be able to write to it, right? Influence it.
That's the next logical step. Which brings us to Helmut Schmidt and his work with random number generators, or RNGs, testing mind over matter psychokinesis.
How does he do that?
He used RNGs based on radioactive decay, a fundamentally random quantum process. The theory was, if consciousness interacts with the quantum ZPF, maybe intention could subtly influence these random events.
And could it?
It seems so. Participants were asked to simply intend for the machine to produce more ones than zeros, or vice versa. And consistently, the output skewed slightly away from the expected 50-50 randomness.
How much of a skew?
Small, but statistically significant, up to maybe 54% in the intended direction. And this wasn't a one-off. Robert Jahn and Brenda Dunne at the Princeton Engineering Anomalies Research Lab, the PEER lab.
Right, I've heard of PEER.
They ran experiments like this for decades. Their final meta-analysis, looking at hundreds and hundreds of similar studies, found the odds against the results being just chance, were astronomical, like 1 in a trillion.
1 in a trillion odds against chance. But hang on, the effect size itself, you said, was small, like 0.2, is that right? If the mind is interacting with this vast ZPF energy sea, why is the effect so tiny?
That's a crucial question, and maybe the answer is in the scale. The ZPF is the baseline coherence of the universe. Our individual fleeting intentions are like tiny whispers against that massive background hum.
So the fact we can influence it at all is the amazing part.
Exactly. It's evidence of the connection. And while 0.2 effect size sounds small, the researchers point out it's actually comparable to, or even better than, the effect size seen for some pretty common pharmaceuticals.
Like aspirin for heart attack prevention or things like that?
Yeah. An effect size of 0.3 for a drug used in heart surgery, for instance, could nearly double survival rates.
Huh.
Small, consistent effects add up to major real-world outcomes.
Okay, so the mind is subtly influencing quantum randomness. If consciousness isn't tied to a specific place in the brain, maybe it's not tied to a specific time either. Remote viewing and precognition.
That follows, yes. The remote viewing work at SRI, with people like Pat Price. He was given geographic coordinates, latitude and longitude, nothing else.
And he could describe the location.
Often with remarkable accuracy. But the really mind-bending detail came from one specific session. Price was viewing a site, described some current buildings, but also described 2 huge water tanks.
Okay, were they there?
They had been there, but they'd been torn down 50 years earlier.
50 years. So he wasn't seeing the present, he was accessing information stored in the field outside of linear time.
That's the implication. If the field is the medium, maybe time and space are less fundamental than we think.
And this connects to Dean Radin's work, showing people reacting before something happens.
Yes, the precognition experiments. He'd wire participants up to measure things like skin conductance, heart rate. Then a computer would randomly show either a calm image or an emotionally jarring one.
And people reacted before the jarring image appeared.
Their bodies did. Their physiological measures showed a stress response a few seconds before the disturbing picture actually flashed on the screen. It's like the body is tapped into the field, picking up future information.
Wow. Okay, individual minds influencing randomness, maybe accessing information across time. What about collective minds? Roger Nelson's Global Consciousness Project.
Right, the GCP. Nelson set up a network of those RNGs, the random event generators, placed all around the world. He wanted to see if major global events, moments when millions of people focus their attention on the same thing, would affect the randomness.
Right.
The most famous example is the O.J. Simpson verdict in 1995, a moment of massive shared global attention. And right at the moment the verdict was read, the entire network of RNGs showed this huge, statistically improbable deviation from randomness. A spike in coherence.
As if all that focused attention acted like one big mind, imposing order on the quantum noise.
That's the interpretation, a collective field effect.
Nelson even found stranger stuff, right? Like influencing the weather, the dry umbrella effect.
That one is definitely way out there for most people.
Yeah.
But yeah, he looked at 30 years of data from Princeton graduation ceremonies, huge outdoor events where everyone, students, families, intensely wants it not to rain. He found a statistically significant difference. About 72% of the graduation days were dry, compared to only 67% dryness on the same dates in nearby towns, suggesting maybe that collective focused intention had a subtle local effect on the weather patterns.
It's a lot to take in. Okay, Let's try to pull this together. We've gone from quantum physics and inertia to light in our cells, water memory, holographic brains, mind over matter, time anomalies, collective consciousness. What's the big aha moment here?
The aha is the convergence. You have researchers in totally different fields, physics, biology, psychology, who weren't necessarily talking to each other, often facing skepticism.
Yeah.
And they independently arrive at descriptions of reality that sound remarkably similar. They all point to this underlying interconnected energy field, the ZPF, as being fundamental. And they all suggest consciousness isn't just a passenger, but an active player interacting with that field.
We're not just bits of matter governed by local chemistry. We're nodes in an information network.
Something like that. We're participating in this coherent, universal matrix.
Which completely reframes things like health and healing. If Popp is right and disease is like static, a loss of coherence in the body's light field,
Then healing could be seen as the process of reintroducing coherence, restoring the clear signal.
and maybe that's what happens in studies like Elizabeth Targ's work with AIDS patients in remote healing.
That's a potential mechanism, yes. Her studies showed that focused intention, whether from prayer groups or healers, seemed to produce statistically significant positive outcomes for patients they focused on, even at a distance.
So the idea is the healer, through focused intention, generates a coherent signal.
And transmits that organizing information non-locally through the ZPF to the patient's system, helping it restore its own coherence.
So this field isn't just theoretical physics. It's potentially the medium for intention for healing. For you, the listener, it's the fabric your consciousness operates within.
Absolutely. And it's challenging. Robert Jahn often pointed out that truly new ideas always sound like heresy at first. This whole body of research, it's like the first few steps into a radically different view of reality.
It suggests the world isn't just something you observe. It's something you actively participate in shaping, moment by moment, through your connection to this field.
And if mass itself is just organized ZPF energy vibrating coherently, well, what could highly focused, coherent, maybe collective consciousness eventually learn to do with that energy? That's the scale of the potential revolution Clarke hinted at. It really does make you wonder.